When I ride a new bike, I can't help thinking to myself, it can't get any better than this. But somehow, within a few months, it always does. Honda engineers always seem to come up with ways to improve what most of us would say is already outstanding performance. Now, this is especially true of motorcycle braking systems. The engineers continually introduce refined and highly advanced braking systems to enhance motorcycle stopping power and control. Now, at first glance, well, some of these systems may seem pretty complicated. You probably said to yourself, where do I start? The truth of the matter is, these braking systems are really pretty logical and can be understood when you look at them systematically. Now today, I'll prove it to you. We'll take a look at two of Honda's most sophisticated braking systems, linked and anti-lock. After viewing this program, you'll be able to identify the advantages of linked brakes, describe how a linked braking system, or LBS, differs from a conventional braking system. You'll be able to identify how a linked braking system functions and list the procedures required for service of the linked braking system found on both the CBR 1100XX and the VFR 800FI. These procedures include inspection, cleaning, pad replacement, and bleeding. We'll also take a look at the anti-lock braking system found on the ST1100A. After this video, you'll be able to identify the advantages of anti-lock brakes. You'll be able to describe how the anti-lock brake system, or ABS, functions. You'll also be able to identify how to access ABS malfunction codes to expedite troubleshooting. So let's get started. The CBR 1100XX and the VFR 800FI are equipped with a third-generation linked braking system. The system was developed to maximize braking performance. LBS was designed to engage both the front and rear brakes when either the brake lever or the brake pedal is used by the rider. Conventional braking systems are controlled by two independent hydraulic systems. The linked braking system incorporates the two conventional circuits, but also adds additional hydraulic circuitry that integrates the two 3-piston calipers at the front and the single 3-piston caliper at the rear. The brake pedal controls the center piston of the two front calipers and the center piston of the rear caliper. The brake lever controls the two outer pistons of the front calipers. The two outer pistons in the single rear caliper are activated by a secondary master cylinder. In addition to the 3-piston calipers, other key components are the link mechanism, secondary master cylinder, proportional control valve, and the delay valve. Let's take a look at how the system works. When the rider applies the brake lever, the two outer pistons in each of the two front calipers are applied. The left front brake caliper is mounted in such a way that it is allowed to move to a limited degree in order to activate the secondary master cylinder. When the brake lever is applied, the rotational force exerted on the left front caliper moves the link mechanism. This in turn activates the secondary master cylinder. This secondary master cylinder activates the two outer pistons in the single rear caliper. So, when the rider applies the brake lever, the 4 outer pistons in the front calipers and the 2 outer pistons in the rear caliper are engaged. Because 4 pistons are activated at the front and only 2 at the rear, there is more braking force at the front wheel. Now, let's look what happens when the rider uses the rear brake pedal only. First, the center piston of all 3 calipers is applied. The left front caliper pivots, activating the link mechanism to the secondary master cylinder. The secondary master cylinder in turn activates the outer pistons in the rear caliper. So the center piston in each of the 2 front calipers and all 3 pistons in the rear caliper are engaged. When using the brake pedal, all 3 pistons come into play at the rear. So there's more braking force generated at the rear wheel than at the front. Other components are used to further refine the operation of the system. The system also uses a proportional control valve. As the rider brakes, the load on the front wheel increases. In other words, weight transfers to the front wheel and away from the back wheel. The proportional control valve is used to modulate the rear brake line pressure to prevent rear wheel lockup and maximize overall braking performance. The valve has 3 distinct stages. At initial brake application, output pressure to the rear caliper increases in direct proportion to the input pressure. As input pressure continues to increase, a cut piston in the proportional control valve activates, causing output pressure to the rear caliper to hold at a constant rate. At a certain point, the decompression piston is moved, causing hydraulic pressure to the rear caliper to decrease. In other words, pressure to the front calipers is increasing at a higher rate than to the rear caliper. All this is done to maintain the optimum front to rear brake balance for maximum braking performance. The linked braking system also employs a delay valve, which actually slows right front caliper engagement to minimize dive. When the brake pedal is applied, the delay valve allows only the left front caliper to be applied initially to reduce front wheel braking force. As pressure increases, the delay valve introduces pressure to the right front caliper. At a predetermined level, the valve allows equal pressure to be applied to each front caliper. Now that you've seen how the link braking system works, let's take a look at what it takes to maintain it. Oh, by the way, always wear gloves and eye protection when working with or around brake fluid. And be sure to have a water-soaked towel handy to wipe up spills. We'll start by checking the fluid level. Here. Inspect the front and rear discs for damage or cracks. Use a micrometer to measure disc thickness. Compare your measurement to the specs in the service manual. Next, we'll check the operation of the linked braking system and make sure the bike is on the center stand. Rotate the rear wheel and push up on the left front caliper. The rear wheel should stop. Now raise the front of the bike. Rotate the front wheel and apply the brake pedal. The front wheel should stop. A common service procedure on every motorcycle is pad replacement. Start by pushing the caliper pistons partially into their bores, but not all the way. Pushing them in too far may damage the seals due to built-up dirt. Check the brake fluid level in the master cylinder reservoir because it will rise. If necessary, remove excess fluid. Be sure to protect all painted surfaces from brake fluid. Remove the pad pin plug and loosen the pad pin. Remove the pad pin and the brake pads. In addition to a thorough inspection, there are a number of areas to clean when performing a brake system service. When you have a brake caliper off, always be sure to clean the inside of the caliper, especially around the pistons. Clean and inspect the caliper mounting pins for smooth movement of the caliper on the caliper bracket. Then lube with silicone grease. Install the new pads. Push the pads against the pad spring, then install the pad pin. Reinstall and torque the caliper mounting bolts. Tighten the pad pin to the torque specified in the service manual. Install and tighten the pad pin plug. Then apply and release the brakes several times until the new pads are in the proper position. That's it. Rear caliper pads are installed in exactly the same way. Master cylinder and caliper service and the bleeding procedure are straightforward. Let's bleed the front brakes first. Make sure the reservoir is filled with Pro Honda DOT4 fluid. Be sure the fluid level in the reservoir does not drop too low while bleeding the brakes. This will prevent air from being sucked into the system. Once the reservoir is full, slowly pump the brake lever several times to bleed air from the master cylinder. Connect a brake bleeder to the outer bleed valve on the caliper that is farthest from the master cylinder. Make sure the reservoir is attached to the brake bleeder. Pump the brake bleeder and loosen the bleed valve. Repeat until there are no more air bubbles visible in the plastic hose. Close the bleeder valve and check the operation of the brake lever. If it feels spongy, you still have air in the system and you need to bleed the system again. After bleeding the air completely, tighten the bleed valve to the specified torque. Then repeat the procedure at the second front caliper. Bleeding the brake pedal line is similar to the steps we've just taken. Start by removing the seat and the seat cowl, the reservoir cap, set plate, and diaphragm. Fill the reservoir with Pro Honda DOT4 fluid as needed. If you're replacing the brake fluid, be sure you have enough clean Pro Honda DOT4 fluid and a large container on hand, because the Link brake system holds a lot of fluid. Once the reservoir is full, connect a brake bleeder to the right front caliper center bleed valve. Use the same procedure we demonstrated earlier. Pumping fluid out of the line until all the bubbles are gone. Then move to the center bleed valve of the left front caliper and repeat the procedure. Next, move to the center bleed valve at the rear brake caliper. Then perform the procedure at the outer bleed valve on the rear caliper. After bleeding the system with a brake bleeder tool, purge the remaining air manually. Follow the steps in the service manual. Now, once you're done bleeding the entire system, you want to tighten all the bleed valves to the torque specified in the service manual. That's it. Now, let's turn our attention to the ST1100A. This model has both linked and anti-lock brakes. Anti-lock brakes were developed to prevent wheel lockup during hard braking or braking on loose or slippery surfaces. This second generation ABS on the 1100A helps to keep braking force within predetermined limits for even better control and ideal deceleration. Key ABS system components include independent front and rear modulators that control the pressure of the brake fluid to the calipers, pulsar rings that rotate with the wheels and signal the wheel sensors, independent front and rear wheel sensors that detect wheel speed and send the information to the ABS control unit. The ABS control unit detects the wheel speed based on input from the sensors and controls the fluid pressure to the calipers. Here's how the system works. The pulsar rings rotate with each wheel. When one of the projections on the outer surface of the pulsar ring passes the wheel sensor, a pulse signal is sent to the ABS control unit. The control unit uses this signal to calculate wheel speed. And when the control unit detects a tendency towards wheel lock, it rotates a crankshaft inside the modulator to close both the cutoff valve and the orifice valve. Now, this reduces hydraulic pressure. Following a predetermined interval, the modulator crankshaft is rotated slightly, opening the cutoff valve only, while leaving the orifice valve closed. This is the pressure hold position. It permits the slipping wheel to recover its rotational speed. Now, once the ABS control unit detects full wheel speed recovery, it rotates the crankshaft back, opening both the cutoff valve and the orifice valve, returning full hydraulic pressure to the caliper. This rapid cycle of decreasing pressure, holding pressure, and increasing pressure provides nearly instantaneous changes in wheel rotation. It also ensures highly accurate control of hydraulic pressure to both independent sets of brake calipers. The ABS contains a self-diagnosis system to to speed and simplify troubleshooting. When the engine starts, the system automatically evaluates the ABS hydraulic circuit condition. If the circuit is normal, the ABS indicator light stays on until the bike starts to move. If the system detects a problem, the ABS indicator light stays on. The control unit stores the problem in its memory, which can be easily retrieved when the customer brings the bike in for repair. To retrieve the malfunction code, turn the key off. Then turn the key back on while pressing the ABS TCS indicator light switch. ABS indicator lights 1 and 2 should illuminate. Hold the ABS TCS indicator light switch down for at least 5 seconds. The ABS indicator lights should go off. Release the switch immediately as the lights go out. Indicator light number 1, which is on the left half, will then start to blink. Count the number of blinks and refer to the troubleshooting chart in the service manual. For example, here we have 1, 2, 3, 4, 5, 6 blinks. The chart in the service manual tells me the problem is probably a faulty rear wheel speed sensor. Let's look at a second example. 7 blinks. A faulty power circuit, which leads us to the page identifying the ABS main relay. The system and service manual pinpoint the problem for you. Now, to clear the memory, press the ABS TCS indicator light switch during the output of the problem code. The problem code is now cleared, and ABS indicator lights 1 and 2, that is, both sides, come on and stay on. Remember that the information we provided can vary from model to model, so be sure to always check your service manual. We've covered a lot over the past several minutes, but as I said at the beginning, these advanced braking systems are pretty logical. Now that you've watched this video, you should be able to identify the advantages of link brakes, describe how a linked braking system differs from a conventional system, identify how a linked braking system functions, list the procedures required for service of the LBS, identify the advantages of anti-lock brakes, describe how the anti-lock braking system functions on the ST1100A, and lastly, identify how to access malfunction codes to expedite troubleshooting. For more detailed information, review the technical features chapter in the service manuals. I hope that after watching this video you're impressed, not only by the ingenuity of these systems, but also by how easy it is to service them. When it comes to braking, Honda's taking a leadership role. It's up to you to take the lead in servicing and maintaining these amazing systems.